Hi, welcome to my video on the transformational form of a hyperbola with center 0, 0. We have an equation here, x squared minus y squared equals 1. Notice that you have x squared, y squared with a minus sign. There's a plus on the x and a minus on the y, so this is what we call a hyperbola. So if we put a 1 here, and a 1 here, which is understood, then we have a squared is 1, a is plus or minus 1, b squared is 1, and b is plus or minus 1. So that you could treat these both of these, as the horizontal stretch and the vertical stretch. But that's in relation to a circle and ellipse. In relation to a hyperbola, we could still get away with classifying A and B as plus or minus 1 as horizontal and vertical stretches. Let me explain further. But before I do that, I want to say that let's look at, notice that the positives with the x and the negatives with the y. So let's look at the x-intercepts of this hyperbola. The x-intercepts is when you make y equals 0. So if we take the equation and put 0 in the place of y, x squared equals 1, x is plus or minus 1. So the x-intercepts are plus and minus 1, which is here and here. So let's look at the y-intercepts of this hyperbola. The y-intercepts is when you make x equal to 0. So we make x equal to 0, and we solve the equation for y. So negative y squared is 1. Y squared is negative 1. So y equals plus or minus the square root of negative 1. Y equals plus or minus I. The square root of negative 1 is an I. That means it has no y-intercepts. So there's no y-intercepts. So we have an x-intercept of 1 and negative 1 with no y-intercepts. So let's look at a table of values. Let's take this equation and rewrite it as x squared equals y squared plus 1. So notice that if you put the values of y in and square them and add 1, the x values are always positive, no matter what the y is. So let's reverse that. If we take the y, the x values, x squared values, are always 1 more than what the y is. So let's take y to be 3, 2, 1, 0, negative 1, negative 2, negative 3. Now I'm doing this to show you the graph of the hyperbola, how it comes about. And later on we'll do a shortcut in graphing them. So I'll take that back just then when I said that y squared is always positive. So that means that the x squared is always positive. So the square root is going to be a plus or minus some number. So let's take 3 and sub it in here. 3 squared is 9. 9 plus 1 is 10. So that means that x is plus or minus the root of 10, which is plus or minus 3.2 as a close value. Let's take 2 and sub in. 2 squared is 4. 4 squared is 5. So x is plus or minus the square root of 5. And the square root of 5 is plus or minus 2.2. Let's put a 1 in for y. 1 squared is 1. 1 plus 1 is 2. X squared equals 2. So x equals plus or minus the square root of 2. So that's plus or minus 1.4. And I'm changing the root to a decimal because you can see how the graph. Put 0 in for y. Put 0 in for y, you get x squared equals 1. So x is plus or minus 1, which is what we have right here. If we put a negative 1 in for y, and negative 1 squared is 1, we get a 2. x squared equals 2, so x is plus or minus the square root of 2, again, which is plus or minus 1.4. Negative 2 in for y. Negative 2 squared is 4. 4 plus 1 is 5. X squared equals 5, so x is plus or minus the square root of 5, which is plus or minus 2.2 approximately. Put a negative 3 in. Negative 3 squared is 9. 9 plus 1 is 10. X squared equals 10. X is equal to plus or minus root 10, which is plus or minus 3.2. So let's graph these ordered pairs. When y is 3, which is right here, x is 3.2, 3.2, 3 here, 3.2 is roughly, let's take an approximation about right there. And when we have y is 3, we also have x is negative 3.2. So there's negative 3. So it's roughly about right there, just right across from this one, same distance. Y is 2. Y is 2 here. X is 2.2. Y is 2. X is 2.2. And 2, let's say it's right there. And negative 2.2. Y is 2. X is negative 2.2, which is right here. And when y is 1, x is 1.4. When y is 1, x is 1.4. That's right there. And x is negative 0.4. So you can see if you put, if the x-intercept is 1, this is not a line. You can see it's shaping up to be a curve. Let's take when y is negative 1. We get a 1.4 plus or minus. When y is negative 1, we get a positive 1.4, and we get a negative 1.4. When y is negative 2, x is plus or minus 2.2. Negative 2 plus or minus 2.2. And a negative 2.2. And when y is negative 3, x is negative plus or minus 3.2. Y is negative 3, so x is 3.2, and negative 3, negative 3.2. So notice that we have a curve. So if you extend it like that, and you extend it down this way, I often say the hyperbola looks like two boomerangs or two parabolas going like this. So I took my time to do the table of values here to show you the shape. But there's something else about that. Notice that this is 1 and 1. So if you take the center of, I didn't do the center of this hyperbola is 0, 0. So if you take the horizontal stretch to be 1 and the vertical stretch to be 1, think about it. If you go up 1, right 1, you get this point here. If you go up 1, right 1, you get this point here. So what we have is what we call in a hyperbola, this is what we call an oblique asymptote. Y equals x. There's an oblique asymptote. Oblique, that means the graph will not cut through this line. And there's also another one that goes through here, goes this way, like this. And that one is y equals negative x. And we'll discuss that in more detail later. Notice this is a broken line. This is the graph here. This graph is solid, all the points on this line, but this is a broken, these two asymptotes are broken lines. The graph will go on and on and on and get closer, and it will get closer and closer and closer to this asymptote but it won't touch. Closer and closer, but it won't touch. Just gets closer. So notice x squared minus y squared equals 1. It has no y-intercept. It has an x-intercept. Now, what about if you take y minus x squared equals 1? Again, we have a 1 and a 1, and we have a squared is 1. A is plus or minus 1. B squared is 1. So B is plus or minus 1. Same as above. And let's check the x-intercept. The x-intercept is when you let y equals 0. The x-intercept is when you let y equals 0. So you make y 0. And you got x squared equals 1. You got x squared equals negative 1. X equals plus or minus the square root of a negative 1. X is plus or minus I, which means it has no x-intercepts. There's no, let me write that down, no x-intercept. So that means it doesn't cut the x-axis. That means let's find a y-intercept. The y-intercept is when you make x equals 0. So we take the equation, put 0 in for x. So y equals plus or minus square root of 1, which is 1. So the y-intercepts are plus 1 and minus 1. So this time it has y-intercepts, no x-intercepts. But the table of values, let's look at y squared equals x squared plus 1. So we put the x values in and work them out for y. You get the same values here, only we're putting the values of x in as 3, 2, 1, 0, negative 1, negative 2, negative 3. So we get, when we put the 3 in and the 2 in and the 1 in, etc., we get these same values that we do here, which is plus or minus 3.2, plus or minus 2.2, plus or minus 1.4. We get plus or minus 1, plus or minus 1.4, plus or minus, so we get the same values, and that's 3.2. So I have the same values, only we have, so when x is, let's take this one, when x is 0, y is plus or minus 1, when x is 1, y is plus or minus 4, which is right here. When, let's see, when x is negative 1, we get y to be, x is negative 1, y is negative 1 here, 1.4, negative 1.4. When x is 2, we get plus or minus 2.2. When x is 2, we get plus or minus 2.2, which is here. When x is negative 2, we get plus or minus 2.2, which is here and here. And we get x is 3, we get 3.2. X is 3, and we get 3.2. And negative 3.2. And when x is negative 3, we get positive 3.2 and a negative 3.2. And notice that it's the same shape, identical. This is solid. Again, we got the hyperbola. Notice the negatives with the x, we have no. The one that has the negative has no intercept. The one that's positive has the intercept. I want to stress that. And again, the asymptote is y equals x and y equals negative x. So the asymptote starts here. So the point 1, 1 is right here. And you go up 1, right 1, up 1, right 1. So the asymptote moves through the center of 0, 0. And notice the slope. So that's the asymptote positive, and this is the asymptote that's negative. Again, we have an x squared minus y squared, so there's no y-intercept, there's an x-intercept. And right here we have the x is negative, so we have no x-intercept, there's a y-intercept. So the two graphs are identical, except this one cuts the x-axis and this one cuts the y-axis. The asymptotes are the same. So it just took a bit of time to do those table of values to explain. So here we go. Let's look at these. Now we have an equation of so we got hyperbole equations for them. So what I'm going to do now is draw sketches of these just to emphasize the intercepts. So notice we got an x squared, y squared, we got a 1 and a 1. So that means that a is plus or minus 1, because a squared is 1. And b squared is 1, so b is plus or minus 1. So if you think about it, we have no y-intercept, so x squared equals 4. So we have x equals plus or minus 2. So we have x-intercepts of plus minus 2. X is plus 2, minus 2. And we have a stretch of 1, a vertical stretch of 1, so up 1, right 1, up 1, right 1, up 1, etc. So there's the asymptote that moves through here because it's 1 over 1. And there's the other asymptote that moves through here. Okay, and they're broken. Asymptotes are broken lines. And it has x-intercepts. So it starts here and goes towards this asymptote like this. So it has x-intercepts. It cuts the x, but it doesn't cut the y-axis. There. And here we also, oh, I forgot to mention, the center is 0, 0. X is 0, y is 0. Center is 0, 0. Here the center is 0, 0. Right here. So again, this is, if you want to think about it, we could put that over 1. And again, a squared is 1. A is plus or minus 1. B squared is 1. So b is plus or minus 1. But another way to look at that, which is very similar, is x squared. If we divide everything by 4 and put it into transformational form, which we'll come up with later, then we could have a to be 2 and b to be 2. So if we go up 2 and right 2, we get this point here. It's the same. We'll get the same asymptote. And this is the same here. If we go x squared divided by 9, y squared divided by 9 equals 1 divided by 3, we'll get a to be plus or minus 3, b to be plus or minus 3. So we'll still get the asymptote as 1, up 1, right 1, up 1, right 1. We still get on the same line, up 1, right 1. So the asymptote is still the same. We'll do a better job explaining it in the next step. I just want to get you to look at that. This one has no x-intercepts. It has a y-intercept. So y squared equals 9. Y equals plus or minus 3. So this one has y-intercepts of plus or minus 3 here. But it has no x-intercepts. So there's your hyperbola doing this. And 3 here. Extend it down. It comes out like this. It goes towards the asymptote, but it won't go through it alongside. So notice it has y-intercepts with no x-intercepts. And again with this one, we have no x-intercepts, sorry, no y-intercepts, it's negative, so x squared equals 25, x equals plus or minus 5. And if we want to divide by 25, divide by 25, we get x squared over 25 minus y squared over 1 equals 1. And again, if you think about it, the asymptote is, if you think about it as the x-intercept, if you want to think about it, this has x-intercept now, so if a squared is 25, a is plus or minus 5, b squared is 1, so b is plus or minus 1. So think of it as going to the right 5, up 1, and going to the left 5, up 1. So the asymptote is there, and it's coming through here. And the broken lines, so it's a 5. Think of 5, horizontal stretch, vertical stretch is 1, horizontal stretch is 5, the vertical stretch is 1, so you form a box, so you're here, and here, and here, so you're up, your right 5, down 1, your left 5, up 1, so you have what we call a box, rectangular box, and the corners, the asymptote passes to the corners of that box. And we have x-intercepts of 5. So there's the x-intercept of 5, negative 5. So this is the hyperbola. Again, this is just an introduction to explain I'm doing this to explain that it has x-intercepts of plus or minus 5 and no y-intercepts. And in this one, we divide by 36, divide by 36, divide by 36. So y squared over 9, x squared over 4 equals 1. So we're dividing by 36. So notice we have y squared, or should I say, my mistake, a squared is 9, a is plus or minus 3. So this has y-intercepts of plus 3, minus 3. And it has, because the negatives with the x, it has no x-intercepts. No x-intercept. Notice this one has no y-intercepts. And again, we're starting with the center of 0, 0. And the center here, the center of this one is 0, 0. The center, x is 0, y is 0. X is 0, y is 0. Notice there's no brackets here. So the center is 0, 0. The center is 0, 0. And we have the x to be 3. We could do the b here. B squared is 4, so b is plus or minus 2. So we have the x-intercepts of no x-intercepts, and the y-intercepts are 3. So the y-intercept is 3 and negative 3. And so the vertical stretch is right 3, and the horizontal stretch is 2. So they're right 3, up 2. So if you go, if you want to form the box, right 3, down 2, and left 3, up 2, and left 3, down 2. So here we are right here. Now that's the box. So the asymptotes will go through the corners of this rectangular box. So the asymptotes go like this. Again, the asymptotes are like a slope. It's like a 3 over 2. You rise. A is Oh, I got, whoop, my mistake. I got A to be 3. I should be 3 up here. And the X is 2. So the corner of the box should be rise 3. The horizontal stretch is 2 here. So the corners of the box should be here. So A is, oh, that's, see? B is 3. My mistake. My mistake. Now careful. B is with the Y, so B is 3, and the A is with the X, so A squared is 4, A is plus or minus 2. So there's the corners. So we go, the vertical stretch is 3, the horizontal stretch is plus 2 minus 2. So rise 3, left 2, rise 3, right 2, down 3, right 2, down 3, left 2. So apologize for that error. I wasn't careful enough. There's the asymptotes. Again, and it has Y-intercepts of 3. It has no X-intercepts because the negatives with the X. So the Y-intercepts is 3. And so, again, emphasize this hyperbola, because it's a x squared, y squared, it has a plus and a minus, has no y-intercepts, has x-intercepts. This one has x squared, y squared with a plus and a minus, has no x-intercepts, but it has a y-intercept. And this one has plus and a minus, x squared, y squared, no y-intercepts, has x-intercepts. So letting y equals 0, you can see that the x squared is 25. And right here, if you take this equation, if you let x equal 0, if you let x equal 0, this is a 0, you get y squared divided by 4 is 9, so y is square root of 9 plus minus, so y equals plus minus 3. Just to make sure. Just be careful. Putting it in transformational form, like you do with an ellipse, gives you the a squared and the b squared. But the a is with the x and the b is with the y. Keep that in mind. A is with the x and b is with the y, as you did in the ellipse. Sorry about that little mix up there. So sometimes you can get mixed up, but just be careful. Which one has the intercept? Which one is either intersecting the x-axis, which is the horizontal, or intersecting the y-axis, which is the vertical. And if you like my video, click on the like button, click on the subscribe button if you're not a subscriber. Visit my math website, www.mathfullyexplained.com, to find more information about me, my videos, and the content on my YouTube channel called Math Fully Explained. Thank you for viewing my video. Hope the video was of some help to you. Bye-bye.